So sedimentary structure जोटा कि produce हुए during for flow of the sediments or during deposition of the sediment. Deposition of the sediment जो कौन सा basin है deposit हुए तो different shape size বা different form में deposit है पर कौन sedimentary structure कौन सा otherwise during movement or during flow, so it can also change the configuration of the bed upon which it is flowing. That is also called as sedimentary structure. So the different type of sedimentary structure that can be formed by mechanical way or chemical way or biological. So by mechanical means हम तो consider करीबा ताले during the flow of any agent river हो कि wind हो glacier हो इस में flow करते हैं मैंने sedimentary structure किसका produce करा इसमें mass movement भी आता है कि gravity through flow होती है during flow of sediments they can form structure when they deposit they can form structure if it is a mechanical force is involved then it is called mechanical structure. The mechanical force involved है ताले mechanical structure mechanical force कौन like river wind glacier gravity equals to mechanical forces. The precipitation होची ताले that is a chemical structure. So during precipitation जब कौन सा structure produce होची ताको chemical structure कहते हैं. और यदि कौन सी fossil বা organism ର skeleton को नहीं deposit होची বা fall produce होची ताको biological structure. खाली skeleton में biological activity जो भी structure produce हुई उसमें tracks trails एगुरा सब जाओ जो तो biological structure. So broadly हमें तीनटा category करिया गोटा जो mechanical structure, chemical structure, biological structure. First हमें देखिए mechanical structure. Mechanical structure first foremost things होची हमारा bedding or stratification. Any sedimentary deposits that occur always in a horizontal manner. That is a law. That हम कहते हैं law of horizontality. The law of horizontality. तो बेड्स में भी तुम्हारा टैबुलर शेप है पारे लिम्फोसाइट शेप है पारे तो गोटे डिपोजिशन हमें जते देखुछंती गोटे बेड को हमें डिफाइन केमति करंती तार किछटा डिस्टिंक्ट कैरेक्टर्स थिबा फ्रॉम अपर एंड लोअर बेड तो जोटु तुमे जानि परथबो सपोज कि आर कलर अलग थिबा आर कलर एटा ब्लैक कलर एटा व्हाइट कलर एटा व्हाइट कलर तो तुमे दीटा व्हाइट कलर ब्लैक कलर तो डिस्टिंग्विश कर परियो तो जोटा ब्लैक कलर बा जो दीटा व्हाइट कलर दे ऑल कॉल्ड एज बेड इसमें गोटे बेड होची जोतरे की the layers of sedimentary rock that have lithological, textural or structural unity that clearly distinguish them from the above and below strata. যদি তুমি upper और lower bed होते तो जानी पड़े. Either तुम्हारा color हो कि तुम्हारा ऐसा sandstone वाला ऐसा limestone. So compositional difference हो जेकों से vary we can determine the bed. So bed जो टी meet करंती, दीटा bed जो टी meet करंती at this point, at this line, sorry, the plane तुम्हें कोई परियो होची that is called the bedding plane or stratification plane. तो bed consider करें पहले हमको गोटे strata thickness greater than 1 centimeter दरकार और the less than 1 centimeter होगा then that is called as lamina. तो बजाय lamina. So these are the different classification of bed on the basis of their thickness. So 1 centimeter to 10 centimeter अधिक वाले sorry 1 centimeter by 10 mm 1 centimeter by 10 mm ରୁ ଅଧିକ ହେଲେ ବେଡ୍ କହିବ ଅଦରୱାଇଜ ଲାମିନା तो डायग्राम देखो कलर कंट्रास्ट अछि देखि तुमे जेतु थिकनेस उटा वेरी लेस अछि देन इट इज कंसीडर्ड लामिना बट इट भी सेवरा कलर कंट्रास्ट करछ डिफरेंट बेड को डिस्टिंग्विश कर परछ बट दे आर थिकर देन दिस और दे थिकर देन 1 centimeter so they are considered as बेड Next come to bed state. Bed state is a group of similar beds or cross beds. Similar bed is together from the bed state square. So the type of bed sets, what of the simple bed set, what of the composite bed set. So simple bed set it consists of two or more superimposed bed. A composite bed set it consists of group of different bed in composition. Texturally, internal structure, they are not similar, but they are genetically associated. Then amalgamation surface market discontinuity between two beds. Like suppose there are two beds like this, they may mark by like this. So this will indicate a discontinuity. So there is some discontinuity in deposition. That was the amalgamation surface. Generally, what erosional surface is that. There are different types of bedding. Bedding, rhythmic bedding, continuously repeat होता है. Cross bed जो थे horizontal bed था, तार से तो कोटे inclined bed तक join करता है. The fine and coarse, the hard condition. Fine sediment winter में produce है, coarse sediment summer में. Fine को darker था है, coarse था lighter था है. The different types of bedding का example लेकर रखूँ. बाहर में तो glaciolacustine deposition. तो glaciolacustine deposition. মানে গ্লাসিয়ার থ্রুরে जो लेक प्रोड्यूस है सपोज धर टार्न लेक है कि पैटर्नोस्टर लेक है से सब लेक रे एटा प्रोड्यूस है लेक रे जो सेडिमेंट तुम्हारा बाय ग्लासियर आसे लेक रे डिपॉजिट हेले से लेयर बाय लेयर डिपोजिशन करो तो समर सीजन रे से माने कोर्सो सेडिमेंट डिपॉजिट करती समर सीजन रे माने कोर्सो सेडिमेंट डिपॉजिट करती जोटा कि तुम्हारा लाइटर कलर था और विंटर सीजन से मैंने फाइनल सेडिमेंट डिपॉजिट करा कि डार्क कलर था तो इ गोटे हमरा पूरा ईयर रो डिपोजिशन को हमें भार को गोटे ईयर रो डिपोजिशन को पूरा भार को है जोटा कि ग्लासियोलैकुस्टाइन लेक रे जो लेक ता ग्लासियर रो मेल्ट वाटर प्रोड्यूस है Then comes to planar bedding, where bedding simple consists of planar bed. Simple you can say consists of planar bed, like this. Those are called planar bedding. So this is your cross bed. Like if two beds are joined by an inclined bed, that is your planar cross bed. Or otherwise, you have a planar bed. Can be laminated, graded, massive. We will discuss. So this thing we will discuss. Like there is a laminated bedding where the result from changing of depositional condition that causes variation in grain size content. So any place where deposition is going on, the energy will not be same for all the time. So sometimes there will be more the velocity of the water or more energy of the water, so that you can deposit only coarser grain. If there are less energy, they will deposit finer grain. So there will be a difference in grain size during deposition. That is why laminated bedding, which cause from the changing deposition condition. So that's why they can form by both by settling of fine size particle from suspension and transport, where energy is very less, fine size deposition will occur, energy is very high, traction deposition will occur. Then massive bedding, which doesn't have any shape or size, you can say it is very doesn't have any internal structure or shape and size. That's why those are called as massive, which you cannot describe in a particular way, a particular shape. Next comes to graded bedding. So graded beddings are sedimentary units or sedimentary deposition which always show a gradation of grain size. Gradation of grain size vertically. Gradation of grain size means you can say from coarser to finer or finer to coarser. By coastal grain found at the bottom and finer grain at the top, or finer grain at the top, sorry, finer grain at the bottom, coastal grain at the top. So there are two types of graded bedding, one normal, one reverse or inverse. So normal graded bedding, coarser at the top, sorry, coarser at the bottom, finer at the top, or we can say hinding upward sequence. Hinding upward sequence. Inverse, it will show coarsening upward sequence. The type of deposition occur in turbidity current. Turbidity current is a water mixed sediments that are flowing at a higher speed. So for this to happen, it must flow on a slopy region. But a slopy region is flow करियो. ताले speed flow करियो. So सब एमती भाव से पूरा गोलिया पानी slope रे flow करूँ. Obviously the speed flow करियो. ताका में turbidity current करते. ताका जो sediments रहता है, they are moving very irregularly, like a turbulent manner. So when they enters to a plain land, suppose you can take the example like this. So this is your slopy region and this is a plain land. So a turbidity current is flowing here. The turbidity current is flowing here and it is flowing very irregularly. So when it is come to this plain land, it will start to settle because the velocity will be lesser here. So they will start to settle. When they will settle, they can form gradation of grain size or graded bedding because basically the portion will deposit fast, then the final according to the velocity. But how the reverse bedding will come? There are two explanations for the formation of reverse bedding. One we call dispersive pressure, another we call kinetic sieving. So what is a dispersive pressure? Should be a type of pressure that apply during the settling of the grain. So dispersive pressure is directly proportional to grain size. So dispersive pressure that blocks the settling velocity. It slower the settling velocity. Settling velocity को slow करे. तो जितने बड़ो ग्रेन थियो तो अधिक dispersive pressure. The larger the grain, the more the dispersive pressure. That means larger grain will settle at a very slow rate than the finer grain. From this mechanism, we can explain how the finer grain will be at the top and coarser grain at the finer grain at the bottom, coarser grain at the top. In this mechanism, we can explain how the finer grain at the bottom and coarser grain at the top. It is because of dispersive pressure, which will inhibit or you can block the settling velocity of larger grain than the finer grain. So that finer grain will settle faster than the coarser grain. Another explanation for the inverse grading or reverse grading is kinetic sieving. It is a simple method, simple explanation where if you put larger grain, then smaller grain can accommodate within the space of the larger grain. Suppose you take the some boulders, then arrange it in on the floor, then pour some sand on it. बोल्डर नेला बोल्डर नहीं थोइदेला तापर कौन बाली ढालला so obviously the sand will accumulate within the pore space of the boulder. That means that will consider that the sand is below and boulder is above it. So it called kinetic sieving. These are the two processes that explains the formation of reverse gradient. So as it is showing gradation of grain size, so obviously it is used as top and bottom criteria. It is used as top and bottom criteria. Top and bottom criteria means you from this structure you can say which is the top side of the bed, which is bottom side of the bed. It is required because sometimes bed is overturned. Sometimes bed is overturned. So we cannot determine which the top side of the bed, which the bottom side of the bed. Because the top side is always younger, bottom side is always older. So if you know the top side and bottom side, it also say that which side is younger, which side is older. So that is the bed here. Can we say which side is top, which side is bottom? So we can always say this side is top, this side is bottom, this side is top, this side is bottom. Suppose gradation of grain size is seen here. Normal graded bedding. It is the normal graded bedding. Now we can say which side is top, which side is bottom actually. So graded bedding, this is the normal structure of the graded bedding. When it will form like this. So this will be the top side, this will be the bottom side. Here we can also say this is the top side because it is overturned. It is overturned during deformation or something. And this is your bottom side. So if this structure is not present, still we can know which is top side, which is the bottom side. But we have to do radiometric age dating because top side is always younger and bottom side is always older. So from age dating we can say whether it is a overturned bed or not. But in the field quickly we can say from this structure which side is younger, which side is older, or which side is top, which side is bottom, where radioactivity is not necessarily required. Today radioactivity दरकारी नहीं. Older, younger. So different types of bedding surface. The bed configuration how changes during unidirectional flow. Unidirectional flow means when water is flowing in a particular direction, that is river it is flowing in a single direction. If you consider sea, it is a to and fro motion, it is a bidirectional movement. But in the river or in streamline flow, they always move in a particular direction. That's called as unidirectional flow. If there is a bed, suppose a bed like this, so water is flowing over the bed. There are particles deposited over the bed. There is certain speed of water required to enter in this particle, to erode this particle. When that velocity reaches, this will erode. When they will erode, they change the configuration of this bed. They change the configuration of structure of the bed. So now it is perfectly planar, it can change it to some other structure when the velocity increases. So with increasing in velocity, the bed form changes to different configuration. Changes to different configuration. So that depends upon the grain size and velocity of the flow. Suppose you think the river is flowing, so at the bottom of the river you will get some structure always. Bottom of the river तुम जो बोलती देखो तो आपको structure पाए. जो जगह velocity आती है तो से structure टा change होगा. हमारे bed रा river रा bed टा पूरा एमती planar भलिया नहीं. तो किसी का undulation structure আছে. So that because of the flow of the river. So the river is stagnant, then you always get planar. Like if take any pond or lake, they always form a planar bottom. But if water is flowing over it, with change in speed of the water or speed of the flow, the configuration can change. Understood? So how the configuration change? It is generalized. You can say structures they form with increasing in velocity. First thing they will produce a current ripple. It will produce a current ripple, which is asymmetrical ripple. We'll study about it the next slide. And the asymmetrical ripple like this. When it is top side, it least side gentle, least side steep. So it is a very small height, up to 10 centimeter or 15 centimeter height. Then when velocity further increases, then these ripples will convert to a dune, which is larger than the ripples. Then when further velocity again increases, this dune will break. This dune will break. All the sand from this crest will deposit on the rock. So it will fill the rock. They again will produce a planar bed. That is planar or flat bed. Planar or flat bed. Then with further increase, this planar or flat bed, they will produce a structure that is called anti-dune. That's called anti-dune. So in the anti-dune, the bed migrate opposite to the flow direction. Bed migrate opposite to the flow direction. Generally, in all cases, the bed always migrate or structure always migrate along the current flow direction. Along the current flow direction. But here in case of this anti-dune, it is flow opposite to the current flowing direction. It migrates opposite to the current flow direction. When further velocity increases, it will also break. It will produce pool and tube. So when it will further velocity further increase, the anti-dune will break. It will produce pool and tubes. These are the sequence of bed from produced in a unidirectional flow. Before this ripple, there is another bed also that is called as your lower plane bed. Lower plane bed. As that will plane bed, then ripple. So from this to this, it is called as lower flow region. From this to this, it is called as upper flow region. From the ripples dune, they are formed in lower flow region. Plane bed, anti-dune, pool, they all were produced at upper flow region. देखा तो ये जो वाटर टा जो डायरेक्शन में फ्लो करछि पार्टिकल का पछू छै तो बैक कले ना इज बिकॉज़ कि तुम्हारा मैंने बताया याडा फ्लो होछि जो डायरेक्शन में फ्लो होछि बेड का तार अपोजिट डायरेक्शन में धीरे धीरे बॉडी बॉडी Let add a move. High speed velocity density, what are both higher speed flow consider. So during this unidirectional flow, ripple of dune case the flow is not in phase with the ripple and dune, but the flow is in phase with plane wave and pull and shoot. In phase out of phase means the structure of crest will not coincide with the crest of the flow. These are the structure that form in different type of grain size. All type of grain size will not produce all type of sequence of structure. It is a very final grain, it will produce ripple upper plane, then altitude. There is very coarser grain, for sometimes there will be no movement. For sometimes there will be no movement. Then it will produce another braid that is lower braid, a lower plane braid. Then it will not produce ripple because coastal grain cannot produce ripple. It will produce dune. Then upper plane braid altitude. There are different type of sedimentary bed sequence that form at different grain size. Review this without Talpata. Then comes to ripples. Ripple already କହିଲି there are heavy undulation on sand surface. So it is from below prod number 1 जोटा कि lower flow region में कहते हैं. The ripple index is measured by that measure the symmetry of the ripple. The ripple index which is length by wavelength by height. Wavelength by height. So it is a general ripple. It is actually current ripple. So current ripple can be two types. So it is ripple index. Another thing also you can calculate ripple symmetry index. So this is the length of star side. This is the length of lee side. So lee side length and star side length. So that will indicate ripple symmetry index, the length of star side by length of lee side. Length of star side by length of lee side, it is your ripple symmetry index. Then for height by wavelength, that is which is height by wavelength, that is also ripple index only. But length of star side by length of lee side, it will ripple symmetry index. There are some problems regarding ripple index. So you can solve that. Next comes to the classification of ripples. So ripple can be classified into two types. One is asymmetrical ripple, that is current ripple. One is symmetrical ripple, that is oscillation ripple. Asymmetrical ripple, it is formed by unidirectional flow during a river or any channel flow. Symmetrical ripple, it can form by oscillatory flow, by it is bidirectional. We form by wave action. So it always has a straight crest. It is a straight crest. So it has a cross section like this. Wave ripple. There is a very sharp crest a rounded trough. But in case of this your asymmetrical ripple, is like this. Both are rounded. Crest and trough both are rounded, and the crest shape it changes with velocity. It can be straight, it can be sinus, it can be catenary, it can be lingular, it can be luted. According to the different shape it is given, that this crest can change to like this or can be like this, the crestal part. So this is a current ripple, this is a cross section of a current ripple. So as it is a unidirectional flow, it can use as paleo current indicator. It is as paleo current indicator because it can show the current direction. So that's in any place you will find a current ripple, it will give a direction of flow. Wave ripple, it cannot give a pilot current indicator because it is bidirectional. It can form when water flow in both direction, it is in ocean condition. It will represent a marine environment. ये marine environment को represent करेगा. So as current ripple, both side is rounded. It cannot be used at top and bottom criteria. Okay, top side देखिए जेमती हो, bottom side देखिए सेमती. But this wave ripple, it has a sharp crest, rounded trough, so it can be used as top and bottom criteria. So from current ripple and wave ripple is used as top and bottom criteria, and current ripple uses paleo current indicator. These are the different shape of crest of current ripple. This is straight, a different type of straight. You just remember straight part. Then this is your catenary part. This is linguard. This is phosphate. Or this is lumen. Then comes to dune. Dune also they are very much similar to ripples. Just they are larger than the ripples. So the windward side of the dune is called as the slip of face. Sorry, windward side में actually there is slip of face. This side is called as your slip of face. This side it is slip of face. This toss side is your B side. It's just larger than the ripple. This is slip face. Sand will deposit here, it will slip like this. So that's our name is slip face or slip of face. The different parts of the dune also applied for the ripples. Of the cross stratification is very important structure. When the horizontal beds are deposited within four-set bed or inclined bed. So inclined beds are bounded by horizontal bed, we can say. Also known as cross bedding. It is a layer within a stratum at an angle to the main bedding plane. These are at an angle to the main bedding plane. These are main bedding plane. And these beds are at an angle to the main bedding plane. So they are meeting the lower bedding plane at lower angle and at the upper bedding plane at higher angle. What we call truncated top, tangential down. That is truncated top, tangential down. So these beds are called as four-set bed. inclined beds are called as forested bed, and this can be called as upper bounding surface. This can be called as lower bounding surface. Can be drawn like this. Draw like this. This is lower bounding surface. This is upper bounding surface, where it will meet the lower bounding surface at low angle, upper bounding surface at high angle. The current always flowing in the dipping direction of the forested bed is like this. So it is formed during migration of the dune or ripple, like this, where sediment will kind of here, where they will deposit and they will overcome the angle of repose, then they will sit here. With gradual deposition like this, they will form a inclined bed. They will form a inclined bed, or what we say forested bed. So crossbed, typically they form various region, point bar of maintained steep, inclined surface, beaches, marine beaches, all region you can find cross stratification. So cross stratification, as it indicate the flow direction, it can be used as current indicator, and we also know the top side and bottom side of the cross strata. That is, this is the top side, this is the bottom side. So top side higher angle, bottom side lower angle. So that's why we can determine what is the top side of a crossbed and bottom side of the crossbed. And here the current flowing perpendicular to the strike of the forested bed or in the dipping direction of the forested bed. So in that condition, we can also know the current direction. So it is used both as current indicator and top and bottom criteria. So current indicator, top and bottom criteria. Both, for both purpose it can be used. Then different types of cross bedding: tabular cross bedding, raw cross bedding, placer, wavy and lenticular bedding, geometric cross stratification, waist shape cross stratification, and herringbone cross stratification. There are tabular cross bedding, so it is formed by, it is also called as a planar cross bedding, where you can see the forested bed meets the upper and lower bed bounding surface at equal angle. It has a broad lateral dimension than the setup thickness. So it is very thinner, you can say, and lateral it is extended. And here the top and bottom bed, the forested bed meets the top and bottom at equal angle. At equal angle. So it cannot be used to determine the top and bottom criteria. It only used for value current indicator. So planar bedding, it is not used for top and bottom criteria. Top and bottom criteria. The draw cross bedding, in which one or both bounding surfaces are curved. So this is your bounding surface. They are curved. Only one is curved. So in that case, it is called as a draw cross bedding, where the bounding surface you can say like this. Both will curve like this, or you can say one bounding surface is curved like this. If any one of the bounding surface is curved, then it is called as a draw cross bedding, like this. Your bounding surface is curved. You can see here. The bounding surface. Then flexure cross bedding, wavy cross bedding, and lenticular cross bedding. This type of cross bedding they are formed due to fluctuating current condition, where there will be current flow for sometimes, then the part will be stagnant. କିଛି ସମୟ ପର୍ଯ୍ୟନ୍ତ କରେଣ୍ଟ ଫ୍ଲୋ କରୁଥିବ ତାପରେ ସେ ଜାଗାଟା stagnant ରହୁଥିବ. So when current will flow, it will produce sand deposition. ଯେତେବେଳେ stagnant ହେବ, when it is stagnant, it will produce mud deposition. So you will get a alternative layers of sand and mud. Sand will show cross strata, cross bedding. Mud will only deposit within them. So you will get alternate sand and mud deposition. When sand percentage is greater than the mud percentage, it is called as a flasher bedding. But flasher cross bedding bedding, flasher lamination भी कोई प्रयोग, तो the thinner flow अधिक. So the mud and sand are 50%, then it is wavy lamination. Mud is 50%, sand is 50%. The mud greater than sand, then it is called as lenticular lamination or lenticular crossbedding. These are the examples. Just remember about the sand mud percentage, according to which we will find flasher, wavy, and lenticular lamination. Then number of hummocky cross stratification. Just remember it is a type of cross stratification that form during storm condition. When there will be storm in ocean, it will produce a hummocky cross bedding which formed in a shallow marine condition. Also in lacustrine environment. So it has a concave up that is called as swales and convex up that is called as the hummocks. The depressions are called as swales and the ridges are called as hummocks. Most importantly, it is formed in storm condition. It is formed during storm activity, formed in shallow marine condition or lacustrine sedimentary. It's in lake or shallow marine condition. During storm condition, it will form. In torrential bedding, where you have alternative coarse current bedded metal and finer horizontal lamina. If the coarset bed is coarser and the bounding surface or bounding bed are finer, then that is called as a torrential bedding. Coarser, coarset bed, finer bounding surface. Then wedge shape cross bedding. When the top and bottom converge at a point, that means the bounding surface they will converge like this. If they will converge like this, then it is called as a wedge shape cross bedding. By the two bounding surface, they will meet with each other. It is like this. If we extend them, they will meet further. Another that is important, herringbone cross stratification, which always indicate tidal region, where will get diversely oriented foreset bed, oppositely oriented foreset bed, which will always indicate a tidal condition. During high tide or during low tide, there will be two directions. So that's why the cross bed will form in two directions. Theta direction cross bed produce or foreset bed oriented. It is exclusively found in tidal conditions. It always represent tidal environment. Mud cracks, like giants of mud cracks, they are formed by shrinking or drying by sun. The mud will shrink or dry by mud by sun. That is called as mud cracks. It is also called as sun cracks. So it is polygonal shape and it is also V-shaped cross section. So polygonal in with the vertical cross section of the V shape. So it is generally common structure during for a in clay region there is no rainfall. If will rainfall in softer region, then raindrop can form impression. That is called rain prints. Then comes to different deformation structure. What are the form structure that form during deformation? During flow of the sediments, they can deform. Like if there is a very dense sediments mixed with water is flowing, they can deform with the flow. So they will form different types of structure. That's why convolute bedding, imbricate structure, slump structure, load cast, plain structure, ball pillow and disc line. ଯେତେବେଳେ ୱାଟର ମିକ୍ସ ସେଡିମେଣ୍ଟ ଫ୍ଲୋ ହବ ମାନେ ତାହେଲେ ସେ ତା ଭିତରେ ପ୍ଲାଷ୍ଟିସିଟି ଟାଇପ ଅଫ ଫ୍ଲୋ ହବ ସୋ ଦ୍ୟାଟ କି ସେମାନେ ତାଙ୍କ ଭିତରେ ଡିଫରେଣ୍ଟ ଷ୍ଟ୍ରକ୍ଚର କ୍ରିଏଟ୍ କରିପାରିବେ। ଆସିବ convolute bedding ଯୋଉଟା କି it is a structure that formed by folding or intricate crumpling ତା କହିପାରିବ of lamination into irregular or generally small scale anticlines and synclines। कौन ଜାଗାରେ ଏମିତି ଲାମିନା ଅଛି ତ ସେମାନେ ଯଦି ଲାମିନା ଗୁରା ଏମିତି ଫୋଲ୍ଡେଡ୍ ହେଇଗଲେ କ୍ରମ୍ପଲ୍ଡ ମାନେ ଆହୁରି ଅଧିକ ଏମିତି ହେଇଗଲେ ତାହେଲେ ତାକୁ ଆମେ କହନ୍ତି କ'ଣ କନଭଲ୍ୟୁଟ୍ ବେଡିଂ। କନଭଲ୍ୟୁଟ୍ ବେଡିଂ ଇଜ ସିମ୍ପଲ୍ ରିଲେ folding or you can say uh, formation of small anticline and synclines of a lamina or a bed। The bed বা লামিনারে যেতে তোমরা small syncline anticline formation হওয়া তাকে আমরা convolute bedding করি। So generally to the depth with the depth को हमें जीवा सेटा the intensity of the fold decreases। Intensity of the fold decreases with depth। It is formed in intertidal flat region, river floodplain, point bar sediments, deltatic deposition. All this type of region can be convolute bedding because all these regions are filled with sediments flow with formed by plastic deformation, which is partially liquefied sediment. Sediments mixed with water. Imbricate structure. Imbricate structure is simple pebbles are aligned in a current flowing direction or inclined to the current flowing direction. So the long axis of the pebble, they all will parallel with each other. Long axis of the pebble would have the parallel heavy, and these will deep towards the upstream side. When dipping goes towards the upstream side, they will incline towards the current flowing direction. So they are very well known for their paleo current indication. So when paleo current indicator is our use here. So the orientation of the pebbles are changing due to flow that also construct deformation. Current will align them into a particular direction before they are like this. They are aligning in the current flowing direction. These you can see. Here you can see pebbles are arranged like this. Next come to slump structure. Slump structure, it is a type of structure formed by mass movement. Sediments on the influence of gravity. So when unconsolidated or semi-consolidated sediments they suddenly move under influence of gravity, they will folded or crumpled like this. So these are called as more a slump structure. Okay, mass wasting or mass movement through the produce. So generally occur in mudstones and sandy shales like this. Irregular folded is irregular folds are produced due to flow. Then another structure that produced due to deformation that is load cast. Load cast is a bulbous depression formed on the base of the bed of the sediment. That means at this base you will find a bulbous depression. Like suppose this is a bed, this is the base of the bed. At the base you will find the depression like this. So this is called as your load cast. It is formed due to differential sinking of the sediment while soft into a less dense sediment below. Suppose there is a less dense sediment below, so the sediment deposited here they can sink to the less dense sediments. So by forming a depression like this, which later consolidated and it looked like this bed has a depression at the bottom. This is called as your load cast because of unequal density or due to density difference there will be unequal sinking that is formed that is formed depression at the base. So load cast these are not actually true cast because cast word is used for erosion and subsequent backfilling. So that's why it is not called as a true cast. They are in the soul of sandstone beds. So it is a type of soul mark you can say, where soul means the bottom surface of something. The soul जो shoe use करते हैं shoe sole that is the under surface of a sole, under surface of a shoe. When comes to claim structure, these are formed where alternative sand and mud are deposited, where tongues of mud will intrude into the sand. Tongues of mud will intrude into the sand. So mud will project into the sand because sand is not completely compacted. Sand is not completely compacted when pressurized. When the clay layer is pressurized, it will intrude into the sand layer. There are various flame-shaped tongues of mud that project upward into the overlying layer, which is commonly sandstone. It is formed by loading of water-saturated mud layer, which are less dense than the overlying sand layer, and will consequently squeeze upward into the sand layer. So when it will experience the loading, it will squeeze into the sand layer. Sand layer is also less dense. In between two, if something is intruded into the sand layer, that means it should be less dense. From these two, mud is less dense. This is more dense, but it is actually also less dense. But if you compare these two, sand and mud, this will be more denser than this. It will form like this. Then another structure that form bore and pillar structure in a similar fashion, sand and mud setting, where this is your sand, this is your mud. Common found in at the base of the sandstone bed, less commonly limestone bed also. They consist of hemispherical, kidney-shaped sand. So what will happen when sand layer pressurize mud layer? When sand layer pressurize mud layer, then the underlying mud layer expel water or it will liquefy the sand layer. So these are structure believed to form resulting foundry and breaking of semi-contour sand of lively sediments owing to the partial liquefaction of underlying mud possible caused by shocking. When it will pressurize, then sand layer will liquefy. So when it will liquefy, these sediments they will detach and will fall on the mud layer. Due to liquefaction, the mud layer also it is less consolidated. The sand can intrude into them or deposit as pillow shape or ball shape at the base of the sandstone. The desandplant structure, these are structures that form by expelling of water also, what we call dewatering structure. This is tomorrow ellipsoid shape, this shape that horizontal to the bedding, parallel to the bedding, and perpendicular to the bedding with the pillar structure. These shell pillar both are dewatering structure. They always form with associated with each other. So one is nearly vertical or cross cut the bedding, one is parallel to the bedding. That is your D shell pillar structure. Then comes more erosional structure, bedding plane markings. So erosional structure channels, these are U-shaped or V-shaped structure that form due to flow of water through softer sediments. It will form a channel. So they are structure that show U-shaped or V-shaped cross section, which is caught across earlier from bedding and lamination. क्योंकि bedding और lamination को earlier from bedding lamination को caught करें. क्योंकि वो V-shaped और U-shaped का produce करे channel. Simple river हो कि जेकोनोसी running water हो, they always form channels. Then the channels may fill with sediments. The channel may be after flow due to flow, the channel can be formed by erosion. When flow velocity will decrease, they also can deposit by sediments. So today it will found very common in fluvial and tidal sediment. Sometimes they are deposited, they are filled with sediments, which is very different than the surrounding thing, or surrounding rock. The core and fill, the name will suggest what type of structure is this. You have to erode, then fill. That means a structure that is formed at higher velocity followed by lower velocity of flow. First there will be higher velocity of flow, it will erode, form a depression, and that depression is filled by when velocity is decreased. So these are thought to be formed by result of core by current and subsequent backfilling as current velocity decreases. It is a very small asymmetrical trough, but the axis pointing downstream is the axis pointing downstream. So you can find it the pillar of bridges. If the bridge or pillar requires, you will find this type of thing where there is always water. So group cast is also that type of structure, score and fill structure. But if you are saying cast means it is erosion and backfilling. So group cast is a elongate or nearly straight ridges that is formed when any sediments that dragged over a softer sediment. So today, when a pebble or couple, it is dragged over a softer sediments. यदि कौनसी softer sediment over a pebble got a kind of empty, that will produce a depression. If you drag any pebbles that on a softer sediment, it will produce a depression. So that depression again filled by sediment, so it will produce a elongate ridge, that is group cast. As it is producing a elongate ridge, that indicates it is formed in a laminar flow condition. Sometimes it produces a V-shaped pattern, like that is called the chevron mark, where V that will point downstream. So it will indicate, it can indicate the current flowing direction, where a V point downstream. So group cast generally they are common in soles of turbidite beds. Soles of turbidite bed means at the base of the turbidite beds. Then similar another structure is your flute cast, which is also formed by erosion and backfilling. It has a very bulbous nose which indicates towards the up current direction. Like this, it has a bulbous nose like this, which is up current, that means current is flowing in this direction, and the relief of the structure decreases towards the down current. Down current means the structural relief decreases, and it is a very well known paleocurrent indicator, so it can easily interfere the pyrocurrent. It is formed by some obstacle where the velocity will be greater, then it will erode, form a depression. When velocity will decrease, it will filled by sediments. That is your fluid cast. Then some marking will form when sediments will transport through bed with saltation action or a rolling action. So simple, if we say during saltation action, it will produce skip mark, or during rolling action, it will produce roll mark. During saltation, it will bounce up from the bed, then again cross the bed, again bounce up from the bed. At that time, it will also produce depression. Those are called as bounce mark, bross mark, and prod mark. So in a bounce mark, it approaches the bed at a very low angle and leaves the bed also at very low angle. But in case of bross mark, the tool approaches the sediment at a very low angle, like for bounce mark. What is the difference? It is the difference. This is your axis of the paper. So it is now inclined towards the down current direction. This is the current flowing direction. It is inclined to the down current direction. But in case of your tool mark, bross mark, it will be like this. It is inclined towards the up current direction. It will like it is approaches the bed at lower angle and move like this. So that is the basic difference between a bounce mark and bross mark. So prod mark, it approaches the bed at higher angle and swept at higher angle. Then roll mark because of rolling action, skip mark because of saltating effect. So all the biogenic structure can be called as a trace fossil. So where tracks, trails, burrows, borings, they all are considered structure. Any footprints, any moving impression, any dwelling thing, anything can be considered as trace fossil also biogenic structure. So it is called as ichnofossil. देखो, so biostratification, it is the position of strata or layered by some biological organisms like algae, stromatolites. Then you can also find graded bedding of biological origin where you have different size of fossil that are arranged in a particular gradation condition. Erosion, it is boring, biting or biting. When excrement, it is to excreta fossil, that is the coprolites. All the fecal pellets or the fecal matters, they will come under coprolites. These are the main type of biogenic structure. When classified the chemical sediment structure in two types, one is the nodules, one is concretion. Both are spherical shape, one is small, one is large. The nodules formed by replacement deposition and concretion produced by precipitation deposition. All are like this, concentric structure. They all are concentric structure like this. So concretion can be carbonate concretion, can be siliceous concretion. The carbonate concretion is a two types. One is calcrete, one is caliche. So calcrete it is called as consists of interlocking crystal of calcite, which is harder than caliche, and it also called as hard pan. Caliche is very thinner and it is formed by alternative wet and dry climate. It is formed in Bado zone. कि normally तुम देखते हो कि बेसी wet and dry climate है लेकिन चोपा छाला वाला माटी रू है नहीं से वाला होची कौन caliche है ना siliceous से तुम आसवा दीटा geode और chort. The chort will show concentric internal structure and geode will show a cavity within its structure. Geode any तुम्हारा siliceous concretion with a cavity within it. That is called geode. And it can also include manganese nodules. That is also an important nodular structure. So these are different chemical sedimentary structure. For sedimentary structure, you have to follow Sandbox, Sengupta,